So calculating for 1 kg of food, okay, so you always use the basis, right? Like you've learned this with Dr. Fpe rules, okay? So it's easier to solve the problem with like some basis. So you assume for calculating 1 kg of food, okay, initial moisture is 80%, means 800 grams of moisture are associated with 200 grams of dry matter, right? They have 80% of water. Okay, so final moisture, you want to dry it until 10%. So it means 100 grams of moisture are associated with 900 grams of dry matter. Okay, so when you dry 1 kg of food, okay, so let's say you dry them until final moisture 10%. So will the dry matter change? After you dry it, will the dry matter change?
No.
No. Yes, that's right. So when during drying, as I said in the previous slide, is only removing of water molecule, the water content. So the dry matter still remain the same in 1 kg. Okay, so you want to know, okay, let's say how many gram of moisture is associated with 200 gram of dry matter at 10%, right? So you just do this simple equations. Okay, so you will get 22.2 gram of moisture are associated with 200 gram of dry matter. So when you double check, okay, 22.2 gram divided by total amount of sample means it's 222.2 gram times 100%, you get 10% final moisture. You get me? Just double check on me. Or I try to write the whiteboard. Okay. I try to write the whiteboard. Okay. um, and Okay, everybody, can you see the whiteboard?
Yes.
Yes, right. So this is like for the final products. Okay, 10% water content means that you have 900 grams of dry matter associated with 100 grams of water moisture. So when you want to add 10% of moisture, so it means at 200 dry matter, you will have how many water? So you will do this 200 divided by 900 times 100. So you get 22.2 grams of moisture. So when you want to double check, so the moisture content of the food, so 22.2 grams divided by the total amount of the products, which is 200 plus 22.2. Okay, means 22.2 divided by 222.2 times 100, you get 10%. So it means the final products you have water is 22.2 grams of moisture. Clear? Firdaus, clear? Yes, right. Okay. So how about Unku? Unku no Safika?
Clear, doctor.
Clear?
Yeah.
Okay, good. All right. And then I assume all of you are clear. If you don't, you can privately talk to Firdaus and Unku. They are clear already. Okay. So don't be shy. Okay. So all right. And then I want to move on. Okay. I save. Stop. Okay. And then share back. Okay. Okay. All right. Okay, now, so because you only remove the water, the dry matter still the same for 1 kg of initial food. Okay. So then 1 kg of original matter must lose how many grams of moisture? So it means like originally you have 1 kg of food, you have 800 grams of water. So in order to reduce them until 10% of water content, you have to remove how many grams of moisture? So you will have this 800, okay, minus 22.2 grams. So you have means you have to remove 778 grams of moisture in order to get the final moisture content is only 22.2 grams of moisture. Means you have to remove 778 grams of water from the initial 1 kg of food. Okay. Mirza, understand?
Yeah, quite.
Okay. How about Azril?
Yes, doctor.
You understand, right?
Uh, halfway through.
Halfway through. Okay. Just look again. Okay. So calculating for 1 kg of food, 80% initial, 80% of moisture content means in 1 kg you have 800 grams of water. So you want to reduce them to 10% of moisture content at the final product. So you already calculated, so you know dry matter will not change. Okay, the dry matter will always 200. So you calculated already. In order to be 10% for this dry matter, you must have must only remain 22.2 grams of moisture. Okay, you must only have 22.2 grams of moisture at the product, which have only 200 grams of dry matter in order to claim the product as 10% moisture content, right? Okay, so means initially you have 800 grams. So you have to remove, so minus this one, minus the 22.2 means you have to remove 778 grams of moisture from here. So remaining only 22.2. So 800 minus 22.2, you got 778, right? So means 800 minus 778, you got 22.2 grams of moisture. This is the moisture that you have to remove in order to have only 22.2 grams of moisture left after drying. Yes. Better don't here. Yeah, better don't round off yet. Yeah, just 1 decimal point because it's only 2 digits here. So better have like 3 digits. Okay, all right. So and then everybody clear this part?
Yes.
Yes, right?
Doctor,
Yes.
I would like to ask um, from the 22.2 gram, it means that the amount of water that need in the dry matter.
That's still left in the dry matter. Yeah, still left together with the dry matter.
Oh,
The
okay,
final
okay.
product. Yeah, final product. So the final product will have 200 grams of dry matter plus 22.2 grams of water. So the moisture content of the final product will be 10%. Plus 22.2 divided by the sum of the dry matter and water will be 222.2. So times 100%. So means it's 10%. Right?
Okay.
All right. So and then heat energy required for 1 kg of original material. So equals to heat energy to rise temperature to 100 degrees Celsius plus latent heat to remove the water. Okay. So this one is from the formula that you maybe you haven't learned this before. I will write down in the whiteboard. Okay. X. So capital Q is equals to total amount of energy. This is hard to do the I think cannot write the underscore, underscript, upper script here. So it's CP, all right, means specific heat, all right, times M, the mass, times delta T. Okay, so this is different than the small letter for Q. All right, the small letter for Q, let's say X Q. Okay, Q equals to example UA delta T, right? Okay, so this is rate of heat transfer, but capital Q is the total amount of heat energy. Okay, so the unit is different too. It's joule, it's energy, right? Or kilojoule. This is rate. Different Q, capital Q and small q, they have different units. Everybody clear?
Yes.
Yes. Okay. All right, good. So I try to save this. All right, and then stop sharing. Okay, so you can see heat energy to rise temperature to 100 degrees Celsius. It's not about the rate of heat transfer, it's the energy. Heat energy is the capital Q. Okay, this is the temperature difference. Okay, 3.8 is the specific heat of the water or the food.
Food.
Food, yes, specific heat capacity of the food. Okay, and then times M. Where is the M? There's no need to write M here, right? But you can write that too, because you are calculating for 1 kg, right? It's times 1. So it means it's the same, right? No need to write, also doesn't matter. It's the same. But you can write it 2 times 1. Okay, M is 1 kg. Okay, plus latent heat to remove water. Okay, so the latent heat is given in the questions 2257 kilojoule per kg. So here, the latent heat of vaporization of water is given 2257 kilojoule per kg. Means to remove 1 kg of water, you have need this latent heat. Okay, 2257 kilojoules. All right. So, but we are not removing 1 kg, right? So you calculate the rate. You are just removing 0.778 kg of moisture. So you times this, right? Okay, this is the amount of water removed times the latent heat. Okay, this is for per kg, but you are not 1 kg yet. Let's say you just remove half kg, so the latent heat is divided by 2, right? Okay, so now it's 0.778 times this, so you plus this 2 together, you got for 1 kg of original material, the heat energy required is 2056 kilojoule. Okay, Firdaus, clear, Firdaus? Okay, good. All right, this is for 1 kg of the original material, the food material. So now the last questions, they ask for per kg of water removed, because for per kg of food material, you just remove 0.778, right, kg. So now as 2056 kg are required to remove 0.77 kg of water. Again, you do the equations that I showed you before, like this, the whiteboard. If you do this simple equations, okay, so you write here 2036 equals to 0.778 kg, x equals to 1 kg, and then x equals to 1 over 0.778 times 2056, right? And then you will get per kg. Just use this simple, solve this simple equations like this method, right? Okay, stop sharing. Go back here. So you will get, so if 0.77 8 kg of water need this quantity, so 1 kg need this, all right, 2643 kilojoules. Okay, everybody clear?
Yes.
Okay,
Yes.
yes, very good. All right, okay, we will move to next slide. Okay, so heat transfer in drying. Okay, so we have been discussing the heat energy requirement for the drying process. Okay, so the rate of